want to go through a couple examples from each one, kind of point out where I think people, well, not where I think, where I know people made sometimes some really minor mistakes. First assignment, first review assignment goes back and talks about domain, range, end behavior, things like that. So let's take a look at this. How about this first one? We want to know what's the domain of the function written as an inequality. So I think one thing I got to tell you here is don't just rush into immediately writing an answer down. Always, especially on tests, always take a second and force yourself to just think about this and wrap your brain around it, and then you can jump in and maybe try to answer a question about it. But so let's think about this. Domain. What's domain asking for? X values. Good. We want all the X values where this function exists. If you think of it in ant terminology, then those are going to be all the places, the X values that an ant could walk on as he walks this function, right? So there are X values, and so one way I think is sometimes useful to think about this would be, what if we took the function and we just squashed it down onto the X-axis? Where would it leave a mark on the X-axis if I squash this thing onto the X-axis? So what's the left endpoint going to be at? What X value? So -7. So it's going to start there. It's going to be a solid endpoint, right? Because that endpoint is solid, right? So the ant can step on X equals -7. He could step on all the X values up to what upper limit? 5. Do I put an open circle or a closed circle? Open circle. So this is what I want to graph right there, isn't it? I want to write that as an inequality, and so what's that going to look like as an inequality? So I'm going to say what? X is greater than or equal to. Good, because we have to include -7. So X is greater than or equal to -7, and what else? Less than +5. That includes, everybody agree, that's what that interval right there is, right? Greater than or equal to -5 or -7 and less than 5. Okay? And we got it. How about that? Okay, so next one. How about one like that? Let's see, which one of these is better? Doesn't matter. Let's do this one. How about? Okay, so how about this one? What are the values of the domain here? And just ask yourself, is it restricted? On the last one it was, right? On the last one there was clearly a left endpoint and a right endpoint. It was restricted. Is this one restricted? No. So then how am I going to say that using interval notation, right? Interval notation is not an inequality. That's the one where we're going to put a comma separating the left endpoint and the right endpoint. So what are those going to be in this case, though? -infinity. The ant goes forever to the left and the right. So we're going to write that as X is greater than -infinity, right? And less than what? How do I say all possible values? Yeah, less than positive. I could put the positive if I want to. I don't have to. I can just put infinity. Either one's going to be correct. Okay. Oh, what did it do? What did I do? Oh, interval. Whoops. You're right. My mistake. Did it tell me anything? No, it didn't. Okay. Negative. Now, what kind of endpoints do I put on this? Parentheses, right? Because I can't include the endpoints because they're not numbers. They're infinities. So that's what we want. Interval notation. There we go. All right. What about ranges? Let's look at quickly. We'll find one on here. How about this guy? Think about the y values now, right? Range is a y value issue. So if I wanted to think about this, there's a couple ways to think about it, right? So thinking in ant terminology, I want to know what are all the y values that an ant could walk on, right? So it's going to be everything between y equals -2 and -10, right? If I were to squish this onto the y-axis, it would be this interval, right? But I got to know what kind of endpoints. Am I going to include -2? I am. The ant can actually stand on, if he's standing on that point right there, his y value is -2. So I got to put a closed endpoint, and then he could also stand on -10, right? So I got to put a closed endpoint there. And so if I want to write that with interval notation, what's that going to look like? What kind of, that's where I got the comma, right? Interval notation is the comma. What's going to go there? -2. Oh, hang on a second, though. Let's try that. What's wrong with that? I need what kind of parentheses? Brackets, but there's still something else wrong with this. What's wrong? Riley, do you see anything wrong with that?
No.
So think what this is saying. X is, that's supposed to be a comma. It looks like a 1. Let me make that a comma.
The 10 needs to go first.
Yeah, it does, right? Because remember that when we write an interval, it has to always be like a number line. It has to go from lesser values to greater values. Well, what's bigger, -2 or -10? -10, aha. So that needs to be the bottom of the limit, right? So I'd have to go back and change this to -10 to -2. Now that works, doesn't it? If I thought of that as an inequality, that would be x is greater than or equal to -10 and less than or equal to, because of the brackets, -2. Did I say x? I think I did. I should have said what variable? Y. Okay. All right, so what about, okay, they want this one. Let's do this one. They want this one as an inequality. I want to write an inequality here. So what's the range then? What are all the y values that the ant could stand on? And let's look at one word here real quick. The red line is an asymptote. Okay, that's a word you may not have heard. I don't know if I've said it or not, but even if I did, it may not have stuck. What's it mean to be an asymptote? As the ant walks to the left, for example, describe his y value. It looks like it's getting pretty close to the same. What an asymptote means is that it's going to get closer and closer and closer to y equals 4, but never get there, right? It's like me walking to the door. I'm going to cut my distance in half with every step. I never actually get there, but that's the value that I'm approaching, right? So then he never quite gets to y equals 4. What's going to be the upper limit of his y values? 4, right? He just doesn't quite get there. If I were to squish this thing onto the y-axis, I'm going to get this interval that goes from +4 down forever, agreed? The function just goes down, the y values go down forever if he walks to the right. But what kind of an endpoint do I have to put up here? It's got to be open, right? It's got to be open because it never gets to that line, right? Okay, so Bailey, how am I going to say that then? I want to say the y values as an inequality. So y is going to be, what's going to be the bottom limit, or is there one? There's not. So it's going to be greater than, how do I say that? If there's no bottom limit, -infinity. Good. And what about the top? Now I have an open circle, so am I going to use less than or equal to? Less than. And what's the top limit? Y equals 4. That's my answer. Okay. Make sense? Okay. Got to get that. Remember, I got to use y instead of x. If you use x, I think I probably have it set up. Let's just see. I think I was nice, and I think I actually included an answer in there. So if you did put an x in, it gives you credit, partial credit, and tells you what you did. Let's just double check. So -infinity. If I put in an x by accident, what's it do? No, I guess I wasn't very nice about that. So it marks it wrong. But if I put in a y, I got it. Okay? Gotta be careful about that. Real common mistake. Okay, end behavior. Let's look at one of these. Let's look at a different one first. So what does this mean here? So as somebody interpret this for me. What does it mean as x approaches infinity? Where's the ant walking on the function if his x value is approaching infinity? Okay, good. I'm seeing people pointing that way. He's going out to the right forever then, right? As he moves to the right forever, fill in the blank. F of x or y approaches what? Positive infinity. Because as he moves to the right, he's also going up forever, right? There's only going to be a couple things that could happen. Either he's going to go up forever. We could have a function where he goes down forever. We could have an asymptote like we had before where it approaches some value, a y value. Or what if it just wiggled around forever? Then it would never approach anything. There wouldn't be any end behavior. So in this case, we get infinity. Okay, what about one like that? As x approaches infinity this time, as he moves to the right forever, what value is he approaching? Looks like -1, yeah. The y value, everybody agree y is -1? Okay. Okay. Got it? Okay, what about this guy here? Does that one make sense? As x approaches negative infinity, does it approach negative infinity? No. The ant has to stop when he gets up to -8, right? The function doesn't go forever, and so the end behavior is there is none. So I would just enter NA, like instructions say. Okay? Okay, moving on. How about this guy? Increasing, decreasing intervals. Let's look at a decreasing interval. So now think about this in terms of, I know this is dorky, but think about it in terms of the ant once again. If the function is decreasing, as the ant is walking it along the positive x direction, so he's always got to be walking from left to right, what's going to be happening where the function is decreasing? What can you tell me about the ant's movement along the function if it's decreasing? He's walking what? What do you think? Well, no, hold on now. Let me say that again. So use one or more inequalities to write the intervals on which the function is decreasing. So as the ant is moving from left to right, we're always assuming the ant's moving from left to right. I want to know what's going to be happening to him if the function is decreasing. He's going to be walking downhill, right? Does that make sense? So decreasing means that's the same thing as saying that as he goes from left to right, he's walking downhill, right? So where does that happen? Lacey, if the ant walks along this function, you tell me when he starts to walk downhill, just say there. Okay, so right about there, right? At the top. Now when he's actually at the top, when he's standing on the peak, or a maximum, if you use math terms, when he's standing on that maximum or that peak, is he walking downhill there? Not, is he? Because that's the transition. That's where he transitions from uphill to downhill. So that's where he starts to. We're going to put an open circle, and then he walks downhill all the way down to the endpoint, but the endpoint is excluded. Right? So if I squish that interval onto the x-axis, it's just going to look like from there up to there, right? How would I say that as an inequality? X is what? Angelica, how do I say that? X is less than what? So here's the interval. It's going to have a lower boundary and an upper boundary, right? Lower endpoint and an upper endpoint. So it's going to have to be pinched between two values. So x is greater than, what's the x value of the lower limit? -2. So x is greater than -2. Good, that means he's to the right of -2, right? And less than, so he's to the left of what value? 5. Okay. I don't include equal signs because though the interval doesn't include the endpoints, right? That make sense? Okay. So that's my answer. All right, what about one like that? And I'm going to read through the directions here. I think it's important to kind of know what you're being asked to do. Use one or more inequalities to write the intervals on which the function is decreasing. So where the ant's walking downhill left to right. If multiple intervals exist, just separate them with commas. Okay, so describe one place, Eli, where the ant is walking downhill from left to right. When he's, okay, so at -2? At x equals -2? So starting there, right? That's what you're saying? Okay, so let's write the intervals where he's walking downhill in green. Do I include that endpoint? No, because that's the peak, right? So every place from there to the right, he's walking downhill. Good. Where's another place where he's walking downhill? What do you think? Emma, where's another place where the ant's walking downhill from left to right? Okay, say it again. -5, so right there. Okay, at that point right there, as he's walking left to right, he's walking uphill. Okay, so when does he starts walking downhill there? If he's walking in from off the screen here, from -infinity, at the very beginning, when we first see him, is he walking downhill or uphill? Downhill. So we know he's walking downhill every place over there, but he's going to continue walking downhill. Where does he stop? At x equals there, right? So that's at -7. Okay, from -7 then up to -2, walking uphill there. Function's increasing there, agreed? So this part in the middle, we wouldn't include, right? We only have to include the left part where he's walking downhill, stops for a while, he walks uphill, and then he walks downhill again. So we got to say that in two separate inequalities. So how am I going to say the left one? How am I going to say all these x values over here? What do you think? How are we going to say that? Okay, so we could say from -infinity, x is greater than -infinity, and what? Less than -7. It'll take that. If I put that in there, it's going to take it, but it's going to say, yeah, that's correct, but you can write it in an easier way. What's an easier way to write that? Do I have to really include the -infinity? What's another way of saying that? X is less than -7. That's probably an easier way to say it. If I just say x is less than -7, that implies that it's all values of x less than -7, right? If I squish this thing onto the x-axis, isn't that the interval that we get right there? Okay, agreed? Let's see. Carolyn, what about the upper part of this? How do we say this interval where he's walking downhill? Where does it start? What x value? -2. So if we squish that one onto the x-axis, it starts there, and it just goes forever to the right. So how do I say that one? X is less than? Greater than, because it's to the right of, right? Less than always means less than left of, greater than right of, right? So greater than -2. So that's my answer. It's those two intervals where we just separate them with a comma, right? So it should look like it should just look like this. And it doesn't matter what order you put these in. It'll take, and I can even turn them backwards. As long as they're true statements, it's going to take the answer. X is less than -7, comma. Do I put a space? Doesn't matter. If you do, it's fine. If you don't, it's fine. X is greater than -2, like that. Okay? Okay. Where would it be increasing then if we asked about intervals where it's increasing? It's going uphill, right? How about these right here, intervals on which the function is positive? So what about that one? Use one or more inequalities to write the interval or intervals on which the function is positive value. Where is a function positive value? What do you think? Chase, where's the function positive? When we say function, we mean y value, right?
Yeah.
So what's that? Where is that going to happen on the xy plane? Where is the function positive? The y values.
Right where it goes up.
Okay, yeah, good. Where it blows up, meaning it's above the x-axis, right? So it's going to be this part right here. Do I include the zeros? I don't, because when it's on the x-axis, it's neither positive nor negative, right? So I'd have to use open circles. And if I were to write that, if I were to squash that onto the x-axis, wouldn't that just be the interval, that interval, right? Those are the x values. So how would I say that? Where are the x values where the ant is above the x-axis? X is what? What do we get? Greater than some value and less than some value. So it's got to be to the right of -5 and less than or to the left of -3. Okay. All right. What about an average rate of change? Okay, let's do that one. So we want to know what's the average rate of change of the function over the interval from -2 to +6. X equals -2 to x equals +6. So at x equals -2, that's right there, right? We got to go up, and there's the point on the graph, right? At x equals +6, there's the point on the graph. All I've got to do is find the rise over the run, the slope, between those 2 points. So if I connect them with a line or a line segment, how much does it rise? What's the rise? From that point to that point, does the y value change? So what's the rise? 0. It doesn't go up at all, right? So rise over run equals 0 over 1, 2, what is it going to be, 8? Doesn't really matter though, does it? 0 divided by anything is 0. Answer. Okay. What if I had gotten an answer? What if the rise was 3 and the run was 7? What would my answer be? What would it be? 3 over 7. Right, it's the fraction 3/7. 3 over 7. Okay. So linear regression. Raise your hand if you are not sure how to do linear regression. You're still having issues on that. Okay. Raise your hand if you feel like you know how to do linear regression pretty well. Got to vote, one or the other. Give me a yes, I can do it. Raise your hand. Okay. Give me a no, not sure. Raise your hand. Okay. So I think we need to go through them. All right. So here's some data. Maybe I'll kind of abbreviate this a little bit here. So here's some data. It says an object's speed is recorded at various time intervals. The data is recorded in the table below. So then, what do these stand for? What's t stand for? Time in seconds. What's v stand for? Velocity or speed, right? In meters per second. So which is going to be the input? And it kind of tells us down here, we're going to calculate the best fit line is v of t. So which one, v or t, is the input? It's got to be t, because that's the values that we're inputting right into the function. They're in the parentheses. So t is the input, v is the output. So when I want to do something like this then, where do I go to store those values, to input those values, those data points? Where do I go? Not y equals. Where do I go? Stat. I go to the stat screen, and I hit enter for edit, and there we go. Right, so let's see, I'd go, the x values go in column 1, so I got 0, 4, 7, 10. I'm not going to change the y values, I'll leave those just the way they are. Pretend the ones I've got. Pretend these are the correct y values. They're not, but just pretend they are. I will put the y values in column L2. So how do I get the best fit line? Because that's all this wants. It wants the equation of the best fit line. So what do I do? Where do I go? That's a calculator issue, right? Okay, I go stat, calc, meaning calc menu 4. Stat calc 4 puts me on linear regression, right? And then now all I've got to do is go down and hit calculate, and it gets me the answer. Okay, so it thinks about it, and look what it does. It tells me that the best fit line is the line y equals ax plus b, where I substitute that number, the top number for a, and the second number for b, right? So how would I write this here then? The best fit line has the equation. We're going to fill in the blank. V equals, well, v is like our y, right? So what am I going to write there then? Ax plus b. So what is a? A is 3.83, except if I round to 2 places, except is it x that I'm inputting here for my input variable? Not y either. Normally x would be the input and y would be the output, right? We said that for us though, v is the output. What's the input? T. Okay, so our equation needs to be, all we got to do is say, okay, the calculator is always going to use x as the input, but for us, in this actual situation, our input is a t, so I'm going to put 3.83 times t plus b, right? So plus 0. What is that, 75? That would be my answer if I hit enter. It's going to be wrong because I didn't use that data, but you get the idea? So then what about this next one? What about the next problem? They want to know on the next one, same kind of a deal, pretend this is our data. This time they want us to estimate what's the speed at a t value of 10. So how would I do that? A couple ways I could do this, right? The hard way would be I could write down this big long equation and plug in 10. But there's an easier way. If I go back to stat calc 4, if I go down to the 4th row where it says store regression equation. If I go down to store regression equation and I hit y1, so alpha F4 is the shortcut, and I go down and hit calculate, I get the same answer I got before, but this time, as long as I've got my plot turned on, which I do, if I hit zoom 9, so zoom stat, look what it's going to do. It's going to plot the data and it's going to give me the equation of the best fit line. So all I've got to do is ask the calculator to calculate what is the y value when x is 10, or t for us is 10. So remember, wherever I want to do any kinds of calculations using a graph, I just go second calc, and I want value of the function. So I hit enter, and I type in the x or the t value that I want, which is 10. Hit enter, and look what it does. It puts me on the best fit line, and it tells me what the predicted y value, in this case what the predicted v value should be. Okay? That's it. It's going to be wrong here because I didn't put the data in, but you get the idea. Okay, questions? Does that work? All right, last one. This will be a quick one. Transformations. All you're doing here is matching. In each case, we're starting with the blue function, or starting with the red function and ending with the blue function, right? So what did we do here? Did we reflect over the x-axis or the y-axis, or neither? Neither, right? How would we do those though? Remember that if g of x is written in terms of f of x, to reflect over the x-axis, what do? What do we multiply f of x by to reflect over the x-axis? -1. Good. If I want to reflect over the y-axis, what do? That's where I substitute negative x for x. So it's like I'm multiplying x by -1. But this would be neither, wouldn't it? Okay, what about this one here? Is that a reflection? The blue and the red are reflections over what axis? The y-axis. So then that's got to be that answer, doesn't it? Right? I'm multiplying x by -1, or substituting negative x for x. Okay, what about this one right here? Neither. That's not a reflection over either axis, right? How about this one? Looks like it's over the y-axis, doesn't it? Right? So which one? Bottom one. Okay, what about that one? Bottom one. That's over the x-axis, so which one's it going to be? Yeah, right there. Right, I got to multiply f of x by -1. Oh, did I skip one? Oh, I skipped. Oh, what did I skip? Oh, that one didn't show up. Huh. Let's try that again. What? Oh, that's not good. Huh. Well, I'll have to fix that one. Something's wrong with that one. I don't know why. Okay, I'll go in and fix that if there's an issue. Just flag it if there's an issue. Okay, what about this one? Real quick, what's this? So the two graphs above are mirror images of each other. The red graph is the original function, blue is the final function. So the blue one would be g of x equals what then? Which one's that going to be? Reflection over the x or the y? What do you think? Over the y, so it's got to be multiplying x by -1 then. So it's got to be that one, right? And that's because it's reflected across the y-axis. Okay, make sense? What else? Let's scoot down a little bit. Okay, we can do that one. Okay, how would we write this? If g of x is a reflection of f of x over the x-axis, then g of x would be, what am I going to do to my f of x? Oops. Over the x-axis. What do I have to do to f of x to make g of x?
Minus x.
Say it again.
Minus the whole thing.
Say it again, Joe. I didn't hear that.
The whole thing minus it.
Oh, yeah, okay. Multiply the whole thing by -1 to make it negative. Good. Oops. What happened? What did I do wrong? No. Oh my gosh, that's wrong. Huh. I haven't looked closely at these. I just want to see if it does do that. Because that's wrong. If it does. Ah, okay. That should say y-axis there. I'll fix that. Fortunately, not many people have done this one yet, so I can still go and fix it. Okay, so this is the one that, okay, I gotta go fix that. So this is the one where if it's over the x-axis, it should be negative f of x. Okay. All right, that ought to get you going. Okay, so tomorrow I'm gonna let you work on this stuff. What I'm gonna do is just get people in here during TA who